worker holds you in her jaws. Your body hangs over a gap between two leaves, high in the canopy. She presses your head to the edge of one leaf, pulls you across the seam, and silk spills out of you. You did not aim. You did not choose the angle. You did not volunteer for this wall. This is not a metaphor. This is Oecophila smaragdina, the Asian weaver ant, a species that builds its nests by folding living leaves into rooms and sealing them shut with silk. Not one adult in the colony can produce it. The only source is the body of a final instar larva, like you. The glue is silk, the gun is a living baby, and the worker holding it is the hand. Why it sucks to be a baby ant used as a glue gun. To understand how your body ends up in the jaws of a construction crew, and what the colony built before you even arrived, start at the egg. You begin as a small, pale egg inside a chamber made of leaves. Warm, humid, suspended in a tree canopy in South or Southeast Asia. You are an Oecophila egg, a weaver ant. The chamber you are inside was itself built the same way you will eventually be used. Leaves folded together, sealed shut with larval silk from a generation before you. Workers move around you constantly. They carry other eggs, clean surfaces, tend larvae further along in development. One picks you up in her mandibles, repositions you in the brood pile, sets you down. Your position in the nest is not your choice. It never will be. The colony needs you alive, but not for your sake. You hatch. Soft, legless, white, curved. You are not the creature the title promised. Not yet. Too small, too early in development to produce the volume of silk the colony needs. Weaver ant larvae grow through a series of molts called instars. Each instar is a size stage. With every molt, your silk glands develop further, and you move closer to the form the workers are waiting for. But right now, you eat. Workers feed you mouth to mouth. Every calorie that enters your body was earned by an adult outside, in the canopy, in the heat, in fights with rival colonies and predators. You are a cost the colony is choosing to pay, because it needs what your body will eventually contain. You are not a citizen of this colony. You are raw material that eats. Before your body gets picked up and carried to a wall, look at what happens at the building site without you. A group of workers has found two leaves near each other on a branch. These leaves can become a chamber if they can be folded and sealed, but the leaves are alive, attached to the tree, stiff along their veins, and separated by a gap wider than any single ant. One worker grips the edge of a leaf with her mandibles and pulls. The leaf barely moves. She pulls again. It bends slightly. Not enough. She releases a chemical signal and other workers arrive. 2, 5, 10. They line up along the leaf edge and pull together, coordinating through touch and chemical cues. The leaf begins to curve, but sometimes the gap between leaves is wider than a group of workers can bridge. And here, the colony does something that sounds impossible until you see it. Workers form chains. One ant grips the edge of a leaf with her front legs and lets her body hang in the air. A second ant grips the first ant's waist, the petiole, with her own mandibles and extends her body downward. A third grips the second. They build a living chain of ant bodies that bridges the gap between leaves. Other workers use these chains as leverage, pulling leaf edges closer together, until the gap is narrow enough to seal. This is the construction site. Workers provide the labor, the coordination, the body bridging, and the structural force. They bring the architecture to the edge of completion, but they cannot finish. They do not have silk. That is your job. You have molted several times. You are now a final instar larva, the last stage before pupation. Your body is larger. Your silk glands are mature. You are the version of yourself the colony has been feeding toward. Inside your body, silk glands produce a protein fiber. This is your only unique contribution. Adults have the jaws, the legs, the coordination. You have the thread. A worker picks you up. She grips you in her mandibles, your soft body held by a jaw that can cut through rival ants. She carries you from the brood chamber to the construction site, through tunnels of folded leaf walls, past other workers carrying food, past younger larvae still in their early instars. You arrive at a seam where two leaf edges have already been pulled together. Workers are holding the leaves in position. The stage is set. The worker lifts you toward the seam. She presses the front of your body against the leaf edge. Your silk glands respond. Silk comes out. She pulls you across. One leaf edge, then the other, back and forth. Each pass lays down a strand of silk that binds the leaves together. You are not aiming. You are not deciding where the silk goes. The worker moves you. Your body provides the material. She provides the direction. You are the tool. She is the hand. The silk dries. The seam holds. The leaf edges lock together, and the chamber takes shape, a pocket of living leaves. stitched shut by the body of a larva who could not walk to the site on her own. You are not the only larva here. Other workers carry other final instar larvae to other seams on the same nest. Multiple living silk sources, working in parallel, each one held and directed by a separate worker. And this is not a special occasion. Nests need new chambers. Old leaves age, dry out, detach. Storms rip open sealed rooms. The colony's architecture is alive and temporary. The repair crew always needs silk. That means the colony always needs larvae in the right stage. Your development is not just about becoming an adult. It is about passing through the window where your silk glands are active and your silk is available. The worker sets you down. Your silk glands are partially spent. You are returned to the brood area, among other larvae, some younger, some the same age, all of them potential building material. You do not decide when you are picked up again. Here is the part the title does not tell you. In many ant species, a final instar larva transitions to the pupal stage inside a cocoon, a silk casing the larva spins around its own body. The cocoon shields the pupa during metamorphosis, the vulnerable period when the larval body is broken down and rebuilt into an adult. Oecophila larvae do not spin cocoons. They pupate naked, no silk shell, no protective wrapping. The silk that other species use for self-protection, Oecophila larvae use for colony construction. The research does not say your cocoon was stolen. It does not say you once had it and lost it. What it says is this: in this species, the larval silk system is directed toward nest building, and these larvae pupate without cocoons. Whether this represents a trade-off, cocoon function replaced by construction function, or whether it evolved differently, the result is the same. Your silk went to the wall, your body goes into pupation, unprotected. You gave the colony its walls. You do not get your own. To understand how deep this goes, rewind past your own life. Rewind to the queen. A newly mated Oecophila queen lands on a tree after her mating flight. She is alone. No workers, no soldiers, no builders. She finds a leaf and folds part of it around herself. She lays her first clutch of eggs inside this fragile shelter. Those eggs become larvae. Those larvae become the first workers. And when those first workers begin building the colony's earliest leaf nests, they need silk. The first final instar larvae of the colony, the very first generation, can be used to seal the queen's own leaf chamber. The system starts at the beginning. The colony's ability to exist in the canopy depends on larval silk from the first generation onward. The queen does not build the nest alone. She builds the first generation, and the first generation builds the nest with their own bodies. Zoom out from your single body. A mature Oecophila colony is not one nest. It is a network of leaf nests spread across branches, sometimes across multiple trees. The colony is polydomous. One colony, many homes. Workers patrol between nests, carrying food, brood, and chemical signals along trunk highways and branch routes. Every one of those nests was built the same way. Workers pulled leaves. Workers carried larvae. Larvae deposited silk. And every one of those structures ages. Leaves dry out. Wind tears open sealed rooms. Rain soaks through weakened silk joints. The architecture is not stone or wood. It is living plant tissue that changes with the season, the weather, and the tree's own growth. The colony is never finished building. New chambers replace old ones. New leaves replace dead ones. Every repair, every expansion requires fresh silk from fresh larvae. The colony does not stockpile silk. It stockpiles the bodies that make it. The leaf nest protects you from some dangers. Rain runs off the folded surfaces. Wind is buffered by the chamber walls. The colony's territorial workers attack most intruders before they reach the brood. Oecophila colonies are aggressive. Workers bite and recruit in large numbers. They defend territory that can span an entire tree canopy. Rival colonies are fought at borders. The colony's aggression is so reliable that farmers have used weaver ants as biological pest control in orchards for centuries. The ants attack the herbivores that damage crops. But the brood is still vulnerable, and some predators have evolved to bypass the colony's defenses entirely. At least one species of jumping spider, Cosmophasis betaeniata, preys on Oecophila smaragdina larvae. This spider does not fight its way in. It uses chemical mimicry, surface compounds on its body that resemble the colony's own chemical signature. Workers that would normally attack an intruder on contact fail to recognize the spider as foreign. The spider enters the nest. It reaches the brood. It feeds on larvae. You are a final instar larva. You cannot run. You cannot bite. If a worker detects the threat, you may be carried to safety. If not, you are prey. The same body that the colony uses to build its walls, is the body a predator can eat before those walls are finished. Your silk glands are spent. You have been carried to seams, pressed against leaf edges, moved back and forth by workers whose mandibles held you like a pen holds ink. Your silk is now part of the colony's architecture, threads and walls you will never see from the outside. Now, you pupate. Without a cocoon, your body lies bare in the brood chamber. Workers attend you, cleaning your surface, regulating humidity and temperature around you. The colony does not abandon you after using you. It tends you, because you are about to become something else it needs. Inside your pupal casing, your larval body breaks down, tissues reorganize, legs form, mandibles develop, compound eyes take shape. The soft, legless, silk-producing body you have been for your entire life is dismantled and rebuilt into an adult ant. You emerge as a worker, a callow, pale, soft-bodied at first, darkening over days. Your exoskeleton hardens, your mandibles set, your legs carry you for the first time in your life. You are no longer the tool, you are the hand. A worker near you picks up a final Instar larva. She holds it in her mandibles. She carries it to a seam where two new leaves have been pulled together. She presses the larva's head to the leaf edge and drags it across the gap. Silk comes out. The system that used your body now uses your labor. You are on the other side of the mandibles. And somewhere in the brood chamber behind you, a new clutch of eggs is hatching into larvae that will grow through their instars, develop their silk glands, reach their final stage, and be carried to a wall. The nursery that raised you was stitched together by larvae before you. The nursery that holds the next generation will be stitched by larvae after you. The colony does not build with dirt, with wax, with wood pulp. It builds with its young, and its young grow up to build with the next generation of young. That is the system. That is why it works, and that is why it would sucks to be the silk.